Hi, good evening everyone. So, welcome to the week 3 live interaction session for the course Technologies for Clean and Renewable Energy. Sorry for the delay. Actually, my PC went in for an update instantly at 5 o'clock, so that is the reason it got delayed a little bit. So, no worries, we will be starting within a minute. Let me just share my screen. Just a second. Okay, that's fine. I hope my presentation is visible and I am audible. So let's start. So, oh, sorry. I hope my presentation is visible and I am audible. Anyone can please confirm? Okay. Uh, so let's start our session for today. So good evening all. So welcome to the week 3 live interaction session crude oil, for the course Technologies for Clean and Renewable Energy Production. This course is offered by Professor Prasenjit Mondal sir from the Department of Chemical Engineering, IIT Roorkee, under the NPTEL SWAM program. Myself, Pratyumnan, a PhD research scholar from the Department of Chemical Engineering. So I meet you all here every week for the live interaction session for this course for the July-November 2026 semester. So in the last two live interaction session, I hope you people, I mean, most of us will be able to recollect that we discussed about the basics of the technologies for clean and renewable energy production, where we saw through what are the different types of renewable energy resources are there, and we also discussed in detail about the conventional sources of energy that is being currently used for the energy production. And then we also saw the demand or probably the need for shifting the focus from the conventional to the non-conventional resources. So basic reason forms the increasing population and increase in the demand for the energy. However, in case of the conventional fossil fuels, they are depleting in nature. They cannot be replenished back. So since they're depleting in nature, we basically need to look for some other alternate sources of energy, which is sustainable and or is also clean, so that it does not harm the environment. The entire energy that gets produced from these sources is more sustainable in nature. So that's our main goal, or basically main focus of our study. After that, we basically discussed about coal. So we discussed on the basics of coal, different types of coal, their characterization, and then in the last live interaction session, we discussed about the gasification of the coal and direct liquefaction of it. So I hope all of you will be able to recollect, basically, uh, or exactly state the difference between what exactly gasification is and how does it different from pyrolysis and combustion. Is there anyone who does not know, or can anyone explain what is exactly the difference between gasification, pyrolysis and combustion? Anyone? What's exactly the difference between pyrolysis, gasification, and combustion? Just a second. I think I made clear the exact difference between all three process. So, in case of gasification, if you see, it is basically the oxygen to the fuel ratio that we are specifically interested in. In case of, um, you can say combustion or the pyrolysis, that particular ratio is actually going to be different. In case of gasification, you are going to give a more controlled supply of oxygen, whereas in case of combustion and pyrolysis, that percentage is actually going to vary. In case of combustion, you are going to give excess of oxygen. In case of pyrolysis, the process is actually going to happen in limited supply of oxygen. You are not actually going to give oxygen for the burning process. So that's exactly what is the difference that is expected in case of combustion, gasification, and pyrolysis. Obviously, as we discussed previously also, depending upon the type, depending upon the process and the amount of oxygen, the products that you get out of these processes is typically going to differ. In case of the combustion process, predominantly you will receive CO2 and H2O, whereas in case of gasification, you will also have carbon monoxide due to the incomplete combustion, as we are sending only controlled supply of oxygen, whereas in case of pyrolysis, the carbon solid powders will be left over because of the low or less quantity of oxygen. When I say low, less, or basically more, excess, I the reference over here is going to be the stoichiometric quantity. So compared to the stoichiometric quantity, if you are going to supply more oxygen to the system, the process is a combustion. You are going to get CO2 and H2O. If you are going to supply exactly the same amount, or within that particular range, you are going to get more amount of CO. That I mean, you will have CO also in the product stream. If you are going to supply very limited supply of oxygen with respect to the stoichiometric requirement, then you are going to be left out with a lot of solid carbon particles in your product stream. So we discussed about the various types of factors and the kind of reactors that we use for this gasification process. Once after we complete that, we went on to discuss about the direct liquefaction of coal. So over there we discussed about how coal is actually converted to different kinds of liquids. We also discussed about the process that was there. So with this, we actually finished our last live interaction session. In today's, we will be discussing about petroleum products and crude oil in detail. So let me show the, sorry. So in case of petroleum products, as I said, petroleum products as such, if you see the very first thing that comes to our mind is the petrol that we use for our vehicles, cars, bikes, or any kind of vehicle. They usually run on petrol. So petrol as such, petroleum, when you hear the word, the first thing that comes into your mind is that fuel that you use for your daily vehicle or for daily transportation. But it's not just that only petrol is there. Petroleum as such is basically composed of many different products. So today we will be discussing about that wide class of components that comes under the broad term of petroleum products. So if you see, petroleum is nothing but it's the naturally occurring. So as per the definition as it goes, petroleum is nothing but it's a naturally occurring organic compound from within the earth that combines oxygen, carbon and hydrogen. So something that is basically is present within the earth and it contains carbon, hydrogen and oxygen. This petroleum products, as I said, it's basically a broad category that includes crude oil as well as the petroleum products. Again, petroleum products has one of the components is going to be petrol. Apart from that, you can derive several other components. So, which we will discuss in a short time. So, if you are going to discuss about petroleum or wherever you see the concept of petroleum, it's going to be a broad classification which includes both crude oil and petroleum products. So please keep this in mind. Petroleum as such is a broad classification involving petroleum products plus crude oil. So with the origin of petroleum, when we talk about how petrol was formed or how these petroleum products were formed, there are totally two different kind of theories that are proposed. One is your organic theory and another one is your inorganic theory. In case of the inorganic theory, it is nothing but it is assumed that the carbon and the hydrogen they basically came together and at high temperature and pressure they formed oil and gas. This is of inorganic theory. The second theory is going to be the organic theory, which is the most widely accepted theory. So please keep this in mind. There are totally two. Again, this is going to be more theoretical. So try to just for pay attention because it's it's going to be more of facts. So please. So there are totally two types of theory. One is your organic and another one is going to be the inorganic theory. Organic theory is the most widely accepted one. And in case of the organic theory, it is nothing but it is the saturated soil plus the absence of oxygen and high pressure and high temperature, which basically results in the decay of the organic matter, which transforms this organic matter into a source of rock which is called as a kerogen. So two theories, organic, inorganic. In inorganic theory, the carbon and the hydrogen, they basically came together at high temperatures and pressures. This got converted to oil and gas. Simple. In case of organic theory, the most widely accepted one, here in the presence of saturated soil and in the presence of absence of oxygen and presence of high temperature and pressure, the decay organic matter got converted into a material which was called as a kerogen. So from this kerogen, the petroleum products are derived. So this is about the how this origin of petroleum products actually started. Again, when you see there are multiple different types of petroleum products and their broad classification is usually on the basis of the API gravity. API gravity as such means American Petroleum Institute of Gravity. So American Petroleum Institute, they basically devised a term or a term for classifying the petroleum products. So basically this API gravity is nothing but it is basically the density of the petroleum products that you obtain. So based on the density, you classify the petroleum products into three different categories. One is light crude oil, second one is medium crude oil, and third one is a heavy oil. So let me just write this classification. Or you can say, instead of saying types, I'm going to write classification. That would be a better word. So first is the basis. Basis is API gravity, which is nothing but it is basically to it's basically how the petroleum products heavy or light in comparison to water. So basically it is nothing but it relates to the density of the petroleum products. That's all. So based on this, there are totally three classification. One is light crude, second one is medium, heavy crude oil. So in case of light crude oil are nothing but those kind of oil that have a density greater than density greater than 31.1 API. And in case of medium crude oil, it's going to be density between 22.3 API and 31.1 API. API is nothing but American Petroleum Institute. And a heavy crude is going to be something that is having less than 22.3 API. So it's like, how do you define density? Density is nothing but mass per volume. And based on that density, you can actually devise another term called specific gravity. Sometimes the density is also expressed in the form of specific gravity. Over there, what we do is we basically take the reference as density of water. So we basically try to evaluate how dense a particular material is in comparison to the density of water. Similarly, for Petroleum Institute, American Petroleum Institute came up with a term called API gravity, which is nothing but it's a measure of how dense this petroleum products is in comparison to that of the density of water. So for that, they basically devised this API gravity, and based on this API gravity, they classify the petroleum products into three different types. One is light crude, medium crude, and heavy crude oil. So this classification is very important because you may expect questions wherein they would ask you to, maybe they would probably give you the range and ask what kind of crude oil is this, or they can ask you that if this is a particular crude oil, what will be their API gravity. So you can expect questions of similar types from this particular classification because it's important. Now, there is a way to define this API gravity. The formula is API gravity is nothing but 141.5 by specific gravity at 60 degrees Celsius, the entire this thing minus, sorry, 60 degree Fahrenheit minus 131.5. So I hope if you would have been through the lecture slides, you'll be able to see this formula. So in case So how many of you have, how many of you know this formula? Anyone who does not know this formula? Basically, in American standards, they don't express temperature in terms of degrees Celsius. They prefer more on expressing temperature in Fahrenheit scale. So that is the reason if you see in majority of the formulas, things will be expressed in terms of Fahrenheit and not degrees Celsius or Kelvin. So that is majorly the difference, because the Americans are used to express temperature in terms of Fahrenheit. So that is the reason why Fahrenheit scales are, you can observe everywhere Fahrenheit scales and not a degree Celsius or a Kelvin scale. Anyone who does not know this formula, SP gravity, specific gravity. Anyone? Okay. Now, there are totally three major types of petroleum oils that gets most attention. First one is going to be WTI. Second one is going to be Brent blend. And third one is going to be a OPEC reference basket. So these are the, again, see, in the trade, in the petroleum trade, there are multiple different kinds of petroleum or the crude oil that are going to be present. These three majorly receive more interest. So if you want to actually know about more about this, please go through the lectures, or you can also Google. So over there you will be able to find out how each of these category consists of oils from multiple different regions, and you can also learn, get to know about their properties, the percentage of sulfur content in them, and so on. So I'm just going to give it out here that these are the three petroleum products that is getting more attention, but please, you can have always a look at the Google to find out more about each one of them. So as I said, this petroleum is not just a single component. It basically, you can actually derive multiple components from this. So when you try to do distillation, this petroleum products, or we can say the crude oil, can be separated into multiple different fractions, and each of these fractions can be separated out as a different products and they can be used. So in this crude refining process, there are two types of products which are usually obtained. One is in case of crude refining. In case of crude refining process, that is your petroleum process, when you try to derive products out of this using some sort of distillation technique, you will obtain multiple different types of products from this. So these products are typically classified into two categories. One is the primary product, and second one is the secondary products. So, any guesses on what could be the primary products from this crude refining process? Anyone? Yes. Any guesses? You need not know. You can just guess what could be the products that you obtain from this crude refining process. So it can be like diesel, examples are diesel, then gasoline, then jet fuel. And in case of secondary products, so you can get kerosene, something that people previously used in their for their household cooking. Then LPG, that is something commonly being used in today's households. Fuel oil, lubricating oil, like some sort of grease. Then you can say wax. Bituminous wax is one of the products that you can obtain from this crude oil refining process. Sulfur, NaHS, sodium hydrogen sulfate, and you can get uh, and yeah, that's all. So these are some of the examples of the primary and the secondary process. So even so, it may be you may would like to actually keep few of these example. You may would like to remember, because it is one of the important things, because you should have an understanding of what you can actually obtain from this crude refining process. In case if it is the primary products that you're going to talk about, it is going to be three different ones. One is diesel, gasoline, and jet fuels. And in case of secondary products, if you're going to talk about, it's going to be kerosene, LPG, fuel oil, lubricating oil, wax, sand, sulfur, NaHS. So now we basically move on towards understanding or how do you characterize these coals. So there are multiple different physical properties and the chemical properties that you need to actually know, or how to measure them, so that you can understand about this petroleum products. Characterization of petroleum products, like how we learned about characterization of coal, we also need to learn about characterization of petroleum products. And in order to do this characterization, you basically go for some sort of characterization techniques. So you need to know about the different properties of the petroleum products that you need to know, so that you can actually kind of like judge whether a particular petroleum product will be suitable for your application or not. So to discuss that, you need to learn about few different properties. So I'm going to list out one by one over here. Some of them are going to be simple, some of them maybe you know them before, some of them are going to be actually new to some of you. So let's go one by one. So first one is nothing but it's going to be the density, or you can say your API gravity. I hope we discussed this right now, so there won't be any doubts. In case if you have any questions that you would like to ask, please let me know. Then second one is something called as 4 point. Then you have octane number. Then you have cetane number. Then you have aniline point. And then you have acid content. And then you have sulfur, deduction methods. And then you are going to have flash point, and then you have something called as RVP. So I hope density or API gravity will not be of any confusion as of now. It's basically to determine how dense your petroleum products is going to be. And for that, they basically came up with their own term, which is called as the API gravity, which is constantly used throughout the petroleum field. Next comes something called as, before we discuss 4 point, let's talk about octane number. Any idea or anywhere have you heard of this word octane number? Any petroleum engineers who are there in this call who know what is an octane number is? Anyone? No. So octane number is actually nothing but it is. I will read out the definition. So it's basically a resistance of the motor fuel to work. So it's basically going to say for a fuel, motor fuel that you're going to take, what is its resistance to work? That is what is called octane number. So higher the octane number, more is the compression that is required for the fuel ignition. So you basically want, so since I have told the definition now, it is nothing but octane number is nothing but it is the resistance for your motor fuel to work. So a higher octane number means more compression is actually required for the fuel ignition. Now tell me, for any vehicle, for any vehicle, would you like to use a fuel which has higher octane number or lower octane number? It is the resistance for the motor fuel to work. So keeping this my definition in mind, tell me, for a particular vehicle that you take or for your daily vehicle, would you like to use a fuel which has a higher octane number or a lower octane number?
Higher octane number is
I mean, could you explain why?
higher octane number. Higher octane number is very important for the fuel ignition. I think.
Fuel ignition. But then can I say that motor fuel, higher octane number basically requires more compression that is required for fuel ignition. So if I have a lower octane number, the lesser compression will be, wouldn't that be more better?
Oh, that's better for the motor.
No, I'm just asking. I want to know whether a higher octane number is required or a lower octane number is required. So it is correct that a higher octane number is required for a fuel. The major reason being is that what actually happens is, in during the start there are also chances for some sort of a unwanted high pressure explosions that may happen. So suppose if your fuel is going to have a lower octane number, it's not able to suppress these kind of, or is not able to resist these kind of what do you say, unnecessary pressure, expansion or increase in that pressure of the fuel. then there can be chances of having more explosion. So a higher octane number is usually preferred in case of high performance machines where explosions are more frequent. So if asked the question whether a higher octane number is preferred, yes, a high octane number is preferred for high performance or high what you can say, I'm going to put it as high performance machines or high performance engines, because if the lower octane, if you're going to use a fuel with a lower octane number, and in case of these high performance engine, if there is a early, unwanted explosions that may happen, then the fuel will not be able to resist those, and then there can be chances of a big fire. So a higher octane number fuel is always preferred compared to a lower octane number fuel. I hope that is clear, or anything that is confusing. Okay, so basically the thing is, when you are going to actually start the what do you say, equipment or your vehicle, there will be a lot of pressure that will get generated within the system. So because of that pressure, and sometimes because of the high heat of the engine, there may be chances of a unwanted explosion. So in order to basically prevent that, the fuel that you're going to use actually prevents this unwanted explosion from happening. So due to that, a higher octane number fuel is more beneficial compared to a lower octane number fuel. Again, if you have any counter arguments, you can actually let me know before I discuss this further. Okay. So this octane number as such is of two different varieties. One is, or two different types. One is something called as RON, and another one is MON. Any idea on what is RON and MON? RON is nothing but research octane number, and MON is nothing but motor octane number. So in case of research octane number, what you do is you basically run the fuel in a test engine. It's not going to be a real engine, it's going to be a test engine with a variable compression ratio under controlled conditions. And this test usually happens at a 900 RPM. Whereas MON is doing a similar sort of a test, but over there you basically use a 600 RPM range instead of a 900 RPM range. Oh, sorry, you use here a 900 RPM range, and in RON you use a 600 RPM range. So for the test engine, you are basically going to charge it with the fuel and then run it at 600 RPM at variable compression ratios under controlled conditions. Whereas in case of a motor octane number, instead of using 600 RPM for the test engine, you are going to use a 900 RPM. Now, among these two, RON and MON, RON, the research octane number, is widely used one compared to that of the MON, motor octane number. So I hope things are clear. Octane number is nothing but resistance for the fuel to work, so that unwanted explosions do not happen because of high heat and pressure. Higher octane number means more compression is required for the ignition of the fuel. There are two different varieties. One is RON and another one is MON. These two are basically used for evaluating the octane number. So the RON is the widely accepted one. The tests are simple. So you basically take a test engine and then feed it with the fuel, run the test engine for RON at 600 rpm under variable compression ratio under control condition, and then evaluate. In case of MON, similar tests, run charge the system with the fuel, run the test engine at 900 rpm instead of 600 rpm under variable compression ratio under control conditions. So this is about the octane number. Both this octane number and cetane number, these two concepts for a fuel are very important. So they help us to evaluate whether a particular fuel is suitable for this particular machinery or this particular vehicle. So kindly remember the concept of octane number and cetane number. Now coming to cetane number. Cetane number is nothing but a relative measure of the interval between the beginning of injection of the fuel and auto ignition of the engine. So the time interval between the injection of the fuel and then the ignition of the engine, that interval is usually measured through a number called cetane number. Higher the cetane number, higher is the faster is the combustibility. Now so higher cetane number means what happens is the time interval between the time you inject the fuel and then the ignition that going to happen becomes short. So faster is the combustion process. Now, like how I described for octane number, tell me whether a fuel for a particular engine, does it require a high cetane number fuel or a high or a low cetane number fuel? Anyone? For a fuel, does it for a particular engine that you're going to test, does it require a higher cetane number or a lower cetane number, or which one will be preferred, higher cetane number one or a lower cetane number one? So basically, a higher cetane number will be more beneficial, right? Because the delay is going to be short and then the combustion is going to be fast. So obviously, that would be much more preferred, because I don't need to put more amount of what do you say? I mean, I don't need to wait for a longer time for the system to start. So that would be more preferable for me to use a fuel with a higher cetane number. Next, we come to something called as aniline point. Aniline point is nothing but, you take aniline. Aniline is nothing but it's a heterocyclic compound. So the formula is C6H5NH2. So you take this aniline, a certain quantity, and then the lubricating oil or the oil that you are going to test, mix them up. The minimum temperature at which both of them are going to mix together into a single phase, that temperature is called as the aniline point. So you're going to take both the liquids and then you're going to mix them. Initially at room temperature, it might be the case that they both are not miscible with each other, because that crude oil is going to be some higher molecular weight compound compared to aniline. So they may have some sort of hindrance towards interacting with each other. However, if you increase the temperature, there you may obtain a temperature at which both of them will become miscible with each other, or they will basically mix up or dissolve, or you can say soluble with each other. That minimum temperature at which they dissolve in each other to form a single phase is called as a aniline point. So aniline point is typically mentioned as, it is usually expressed in terms of diesel index, DI, diesel index, DI, which is nothing but it's equal to aniline point. That is the minimum temperature at which both aniline and your oil is going to become miscible with each other, or you can say soluble with each other, but mix up to form a single phase, times the API divided by 100. So this is about aniline point. Next you have the acid content. This is nothing but it basically evaluates the amount of free acid present in the sample. Now, if you are going to have the free acid in the sample, you are supposed to neutralize that sample with a base. So, in that case, the base that you are going to use for neutralization is going to be KOH. And in case if you have excess of base in the crude oil, then you are supposed to use some acid to neutralize that base. So, for that, the acid that you are going to use, the neutralizing acid and neutralizing base, I'll write it that way. Neutralizing base and neutralizing acid is going to be perchloric acid. So now question is, why you're supposed to neutralize? I mean, what will happen if there is going to be excess of free acid and excess of base in my crude oil? I mean, why I am particularly interested in knowing the amount of acid or base content in my crude oil sample. Anyone? Why I'm supposed to evaluate the acid content in my sample or base content in the sample? So kindly look at this, because it would be kind of like important to know how acid and base content in the fuel will affect the performance, will affect its performance. Now let's come to sulfur detection method. Again the same question, why sulfur is important to, I mean, check. Like, there are also other kind of components, but we are specifically interested in sulfur. Why? I mean, is there any specific reason? So I can give a kind of a, like, what do you say, relationship. You can try to explain me. High sulfur in the crude means that crude is going to be cheap in quality, so its price is going to be low price product. Now can you explain why sulfur detection method, I mean, why sulfur is important to remove from the crude? Why it is that if the percentage of the sulfur in the crude is going to be more, it's a cheap quality crude and it's going to cost low, whereas if the sulfur content is going to be low, then the crude is going to be of very high quality and it's going to be very expensive. Can you explain the relationship of how the quality is dependent on percentage of sulfur, or why is that sulfur percentage is more, I mean, uh, how does the percentage of sulfur in the crude oil affects the performance of the fuel? Please have a look at it again. I'm going to write the two questions here. I'm going to mark it. Kindly let me know what would be the answer in the next session. How sulfur content in the fuel will affect its performance. So these two I'll cancel it from here. So sulfur detection method, as such, if you see, there are multiple different types of sulfur detection methods are there. So let me just state them one by one. So one method is Wicks-Bond method. It's called weak bond combustion method. Second one is ICPMS. It's called inductive coupled plasma mass spectrometry. It's a mass spectrometric technique. So here we try to use the plasma, and then the plasma actually pulls the electron away from your sample, and then it actually goes and hits the mass detector, from where you can actually see which element and how much percentage of that element is present in your sample. Then you have X-ray fluorescence, XRF. And then you have something called colorimetric method. Basically you do something like you react the sulfur based compound with barium chloride, and BaSO4 starts precipitating. So this is about sulfur detection method. And then we have another concept called flash point. I think this would be kind of simple, right? So, most of you might be knowing this, or you can at least guess it with the word flash. It's nothing but it is basically the temperature at which the ignition of the fuel starts. That is the flash point. So when you apply a ignition source, the temperature at which the ignition starts, the minimum temperature at which the ignition start, is going to be your flash point. And one thing that we are left out with is this RVP. Just a second. Oh, sorry. The thing that we are left out with is PowerPoint. So anyone who knows what is PowerPoint? PowerPoint. There are 2 points. One thing is called PowerPoint, and another one thing is called Cloud Point. So PowerPoint is basically when your petroleum products start to have the ability to flow. And the cloud point is basically when you basically cool the petroleum products, there will be a cloud that will be formed. That temperature is called as pour point and cloud point. So pour point is basically when the petroleum products have the ability to flow. Cloud point is when they form a cloud. They basically cease the ability to flow. They basically get cooled down and then form a cloud over the surface, and then ceases its flow. That is cloud point. Pour point is the opposite of cloud point. So it starts to flow. So this is these are the properties of the petroleum products. So once you have an idea of all this, you will be able to get a complete picture on the type of petroleum products that you have, and you can basically take you can basically judge, you can basically take a stand on whether a particular product is suitable or not, or whether a particular fuel is suitable for the intended application, or whether this particular fuel is suitable for this engine or not. You can get to know these things by doing these sets of characterization techniques. So any questions so far? Anyone? Again, you have two questions that I would like you to what do you say? Find out the answer. One is how acid and base content in the fuel will affect its performance, and second, how sulfur content is going to affect the quality of the fuel. The relationship I gave, higher sulfur means lower its price. So cheap crude, basically. So my question is, why is it so? Kindly have a look at the answer for these two questions and then let me know either by end of this session or probably in the next session. But please do look at the answers for these two. Any questions so far? Because after this we will start with our numerical problems and MCQs. Anyone, any questions? If you do not have any questions, then let's take a break for 5 minutes. I will give the questions to you. So, oh, sorry. Yeah, I will give out the questions to you. Uh, Let us start with some other question. Okay, let us first start with this question before we go to this problem. So, try to solve this question in the break, or so you can ask me any doubts if you have. I'll be here. You can ask me your doubts, or if not, you can please go through this question and then try to solve this. Or if you feel a bit overwhelmed by our discussion, then you are welcome to take a break. But please be here within the next 5 minutes. We will start our session or resume our session once again. So, yeah, it's just only for 5 minutes. So, the slide will be visible to you. I'll be sharing the screen continuously during this time as well. So, please try to solve this problem. This is a very simple one. It's something very similar to what has happened in the tutorials. So, yes. So, any answers? I think we took probably more than 5 minutes, I think. Answers: calculate the sedimentation rate in gravity separation for the particles for the particle size delimiting to delim of 10 micrometers. Particle density and liquid density is given, viscosity is also given. You're just supposed to calculate the sedimentation rate. Anyone? Answers? At least what is the formula that we need to use?
Sir,
Yes.
1.63 into 10 raised to minus 7 meter per second.
1.63 into 10 to the power
Minus 7.
Okay. Okay. So since I got the answer, I will start solving. So what's the formula for calculating the sedimentation rate? So I'm going to write sedimentation rate dp square, or let me put it this way. Let me write it anyway. That's okay. It will take some time, but it will be more clear for everyone. dp square times rho of the particle minus, sorry, this formula is fine. Now dp square is 10 times 10 to the power minus 6, because it's in micrometers, you're supposed to calculate in terms of meters. So I'm going to write it as 10 power minus 5. Times G value is going to be 9.8 times rho P minus rho F, so 1150 minus 1000 by 18 times mu, which is nothing but 5 into 10 to the power minus 2, or I'm going to write 0.05, 0.05. Just a second. If that is the case, then 1 minute. Then sedimentation rate will be nothing but 150 times 9.8 times 10 to the power minus 10 divided by 18 times 0.05, or you can write this as 18 times 5, and I'm going to take that 10 power minus 2 above, so that's going to be 10 to the power minus 8, and 18 times 5. So what will be the, so if you do, let me use calculator. So 150 times 9.8, 1470. 18 times 5 is 90. 16.33. So sedimentation rate is 16.33 times 10 to the power minus 8. So that can be written as 1.633 times 10 to the power minus 7. Yes, answer is right. What is the units?
Is it in meter per second?
Yeah, meter per second. Okay, that answer is right. So this is how you calculate the sedimentation rate, and again here it is a laminar flow. So for the laminar flow, this equation satisfies. In case if the flow is going to be not a laminar, then the equation will change. So that particular condition is we are supposed to assume that condition for solving this problem. Any questions in this one? Anyone, any doubts? Answer is right. It's 1.63633 times 10 to the power minus 7 meter per second. Okay, if you have no doubts, then let's progress. So go through the first question and then let me know the answer. API gravity is given for both gasoline and for kerosene. Now you are supposed to determine the difference between the specific gravity. What's the answer? It's just that you need to substitute this in the formula that we discussed before. Okay, let me give out the formula here. So, so this is the formula. Just use this formula and then you'll be able to find out the answer.
SR is it 0.068.
Okay, so since I received one answer, I'm going to start solving. For those of you who have not solved, then please keep, please try to solve. If you have any doubts, please let me know. So, okay, let me solve it somewhere else because there may not be much space actually. So, this is the formula. So, for one thing, the API gravity is going to be 63. Another one API gravity is going to be 45. Right? Okay. Now I'm just going to substitute. So 63 is equal. So I'll write the expression in terms of specific gravity. So it will be 63, 141.5 by 63 plus 131.5. Yes. Now similarly, the other specific gravity, I think for kerosene, if I'm not wrong, just a second. First one is gasoline, second one is kerosene. So I'm going to put this as 141.5 by 131.5 plus 45. Now you just need to subtract both. So denominator is going to be different. So okay, let us find out the difference. It's going to be 63. We will take the modulus value. So I'm going to take it as 63 minus 45. And the entire this thing divided by 131.5 plus 63 is 194.5 times 45 is 176.5. So what will be the value? Instead, better I can write this as 141.5 by 194.5, which is nothing but 0.727, and this value is going to be 0.801. So difference is going to be uh, 0.074. 0.074. So the exact answer is 0.074. I think it's not there in the option. That is fine. So we should just know how to solve. So answer is 0.074. Is this the answer that you were also getting? Or did you get exact 0.068? Yes.
Sir, I got 0.08 by rounding off. 0.08.
You got 0.08. Okay. I think, can you check the calculation once? I mean, was there any difference with then other than my values?
Sir, I took first two decimal digits for the calculation.
Oh, okay, then fine. Okay. So that then it is okay. 0.80 minus 0.72, so you got 0.08. That's fine. Okay. So anyone with any questions or any doubts on how to calculate this difference in specific gravity? You are just going to substitute the value in that particular equation and then express that in terms of specific gravity and subtract both. Then you will get the difference in the specific gravity. Any questions? Okay, if you have no questions, then before solving this, let's come to um, the match the following. Now you're supposed to match, so column 1, that is your left side column PQ, R is nothing but it's a petroleum product, and now you're supposed to match it to their specific application. So let me know what is the answer. Which one will get matched with what? I think P you can find easily. What about Q and R? Oh, sorry, there was a network connection issue. So let me share my screen. So I was asking what is the answer for the match the following question. I don't know when my network was disrupted, but still, you can look at the question now. So I hope P will be easy to access. You will be able to match to its application. What about Q and R? So P wax is for candle wax. So I think that should not be of any doubt. So P is going to be 3. What about Q and R? So Q will be 1 and R will be 2. So petroleum coke will be used for the coal fire boilers, and this salt will be used for the roads and roofing materials. So kindly remember this, because these kind of maths are following you may expect in your assignments as well as in your final exam. So next, the electrostatic forces of attraction between the droplets can be represented as the four formulas. So you need to let me know which formula is the correct one. I hope it is visible, or let me just. Which of the formula represent the force of attraction between the droplets? Correct. The answers. So it's going to be option. Anyone? What will be the electrostatic force of attraction between the droplets? It's going to be option C, right? K E square D power 4 by S power 6. And what is K? Can you let me know what is K, E, D and S represents for? What does K, E, D and S represents? So I'll just write it here. F is the electrostatic force of attraction. Your K is going to be the dielectric constant, and E is the electric field, and D is going to be the distance, diameter of water droplets, and S is going to be the center to center distance between the two droplets, two adjacent water droplets. So based on this formula, you'll be able to, I hope you'll be able to solve the problem wherein they will ask you to calculate the forces of attraction between the droplets. So I hope this is a direct question. I just asked the formula. In case if you have any doubts, please let me know, or we will progress to the next question. We have like 10 more minutes, so I think 3 more questions will be easier to finish. Any questions? Anyone? Just a second. Oh, okay. In case of no questions are there, then let us go to these last 3 questions. Same amount of aniline and loop sample is mixed or is heated under specific condition and are mixed at 110 degrees Celsius. If the specific gravity of the lube oil is going to be 0.9, determine the diesel index of the oil. So, how do you calculate this? Specific gravity is given and then this aniline point is given. You are supposed to calculate the DI, diesel index. How to calculate? What's the formula? Okay, I'll just give out the formula for the time being. So this is the formula. Now you're supposed to calculate what will be the diesel index. This is not a straightforward problem. So you're supposed to first calculate what is API. Then you're supposed to calculate how aniline point in terms of Fahrenheit. Here the question is in terms of degree Celsius. So you're supposed to calculate degree Celsius to degree Fahrenheit, and then if you substitute the value, you should be able to get the diesel index. Yes, how to calculate this? Sorry. What's the answer? It's going to be simple, right? Let me start solving. So first let me calculate API. Ah, so that is nothing but 141.5 by zero point 0.9 minus 131.5. So what will be the value? So 141.5 by zero point 0.9 is 157.22 minus 131.5. 25.722. 72. Now you know API. You are just supposed to calculate aniline point in terms of Fahrenheit, which is nothing but 9 by 5 times temperature in degrees Celsius plus 32. So if you substitute 110, then it would be 9 times 22 plus 32, which is going to be 198 plus 32, that is 230 Fahrenheit. I hope the calculation is right. Just check. Mm. So then the diesel index is 230 times 25.72 by 100, or you can say 2.3 times 25.72. 59.156. This is the diesel index. Mm. So option B. Any doubts in this? Anyone? Okay, then next move to one question and then we will conclude the session. Cracking in the presence of hydrogen is called hydrocracking. This process occurs under high temperature, low pressure, high pressure, low temperature, high pressure and moderate temperature, low pressure and low temperature, which is correct. It is high temperature pressure and moderate temperature, right? So this is the answer. So any questions in whatever we have solved? The problems? Anyone? Any questions? If you have, then please let me know. Okay, if no doubts, then I think I can conclude the session for today. So let me stop presenting. So if you have any questions, you're welcome to let me know, or I'll conclude the session. Okay, so thank you all for joining today's live interaction session. I hope you found the live interaction session useful. I hope you are able to access the video recordings as well as the presentation. These video recordings and the presentations will be made available in the course content page. So if you see in the course page, then at the right bottom corner you have a problem solving session where you can if you click on that link, you will be directed to an Excel sheet from where you can access the lectures as well as the presentation. My email ID also will be given along with the presentation. So in case if you have any doubts, you are welcome to email me. I will be able to respond to you as soon as possible. Or in case you can also drop down your question in the Q&A section. So I take this as an opportunity to thank Professor Prasenjit Mondal sir as well as the NPTEL team for providing me this opportunity to interact with you all in this Sunday afternoon. Our next session will be on 16th of August, same 5 p.m. to 7 p.m. Till then, have a great weekend, and I hope you work through the course during the weekdays. So let us meet next week. Till then, thank you and bye.